Okay, for my secondary circuit I'm going to have a fairly unlikely situation, which is a building that runs over 2 floors. Bottom floor will have radiators and the top floor I'm going to put heat interface units. So let's just create that arrangement. There's my riser. And we'll have it running up to the floor above, which is going to be level 1. You can see that the level numbers just number themselves automatically, and I'm going to put in say 10 terminals on each of those branches. There's my heat interface unit. We'll make them all 5 meters apart. Okay, so once they're there, I can simply copy and paste them along until I've got the number I want. To link these terminal units to my schedule, my terminal unit schedule, if I go to the schedule, you can see here I've got some data I've already put in. I've got 10 radiators and 10 heat interface units, all with a unique reference and all with duty information and pressure loss information, and I've also specified what control valve I want to use. There's a choice of several different types of control valve, but I'm going to have a TRV for the radiators, and I'm going to assume that the heat interface units come with their own internal valves, so they won't require any valves on them. So to link this schedule to the schematic, I use these numbers down the left, and if I just simply enter those numbers into the boxes, you can see that the radiators start to label themselves up. Okay, now there's a few design warnings that I need to do something about. You can see down here that there's a requirement for a bypass. That's because at the moment I've got no bypass in the system, and if all of those control valves were to close, then the pump might have to operate against a closed head. So now I can get a bypass from the building blocks page. A constant flow bypass would be ideal. I can put one on the end of this run, and if I copy one of those into the end space, that'll connect it up. I need to give it a value. Ideally you need to aim for about between 5 and 10%. I think that's equivalent to about 0.1 litres per second in this particular system, and indeed that's enough to clear the warning. So that's that warning dealt with. I now have a a permanent bypass there, which allows the pump always to have somewhere to pump. Now I need to deal with these ones. These TRVs require some DPCV protection, differential pressure control valve, and it needs to be there and also somewhere for those two. Now the best way to deal with those two is to create a separate sub-branch rather than put individual DPCVs onto those. So I can create a separate sub-branch if I go to the T's here. And then just create a branch. I need to leave space for my DPCV. But I can put my two radiators after that. Okay, so effectively what I'm going to do is I'm going to move those two down to here. So these become 1 and 2, and then the two above can disappear. Okay, and now I can add my DPCVs. So if I take a DPCV and put it in here, you can see it's quite fussy about where it wants to go. It wants to be a bit closer, so I can move it closer by reducing that distance and increasing that distance, and now it's nice and close to where the start of the radiators. I can copy this one down into this position as well, and that should then satisfy that, and my design warnings are gone now. I've got my DPCVs in there in the correct positions, and I think now we have a system which is all completely free of design warnings, and that would be an acceptable system. There's no reason why that system wouldn't be okay. But we can improve things by just allowing some diversity in this top branch. It's very unlikely that these heat interface units are going to call for peak heat output simultaneously, because they're heating hot water, and hot water simultaneous demands are obviously going to be very variable. So there's scope to put a diversity factor in. Now if I go to my building blocks, I can select a diversity factor block and paste that in. But the question is what value to enter, what coincidence factor or diversity factor do we put in? It's very difficult to get that information. Now SystemGuru comes with a program that will estimate coincidence factors for you. If I switch to that program, you can see this is it, and I just need to enter the information here. So if I've got 10 heat interface units, let's assume those are in 10 different dwellings. Let's assume there's 3 people in each dwelling. That gives us 30 occupants in total. And these people in each dwelling are unrelated, so we'll say, well, they could get up at any time over a 3-hour period. And so our peak could occur at any time within that overall range. Let's then just add some appliances. Let's say each dwelling has got a sink, a basin, a bath, and a shower. And that's all the input I need. If I then take a look at the load pan, you can see it's been modelled for you, so that for each dwelling and each appliance you can see the predicted on times and off times. On times are in red, off is in yellow, and if I scroll down you can see how that's being predicted across a 3-hour period. But if I go to the results page, then you'll see those simultaneous demands plotted on a graph. Now this is a modelled system, so each time you run the model you may get a different result, but if we run it 20 times then we should get an idea of the maximum possible coincidence factor. So here we go. You can see that each time the model runs, the highest point gets plotted and remembered. There we go, it's completed 20 runs, and the peak coincidence factor out of those 20 runs is 34%. So we can now go back to our schematic and enter that value into the coincidence factor box. And you can see that's had two effects. First of all, it's dramatically reduced the total flow in this pipe, which means this pipe's going to be a lot smaller than it was before. But it's now telling us that actually we've got too much bypass in the circuit. That's because our bypass amount was based on the previous flow rate. So we can now afford to reduce this to something like a third of what it was before. If I put in 0.04 litres per second as a bypass, then when I come back to the pump, that warning has gone, and again we now have a system which again is complete, but which has also been improved by allowing for this diversity factor. So that's our system drawing done. If we now look at the output pages, we can take a look at the valve schedule. Every valve on the schematic has been cross-referenced on this schedule. Also, if I go to the pressurization unit, there's a calculation of for the sizing of the expansion vessel. All of that done in accordance with the British standard. If I go to the pump schedule, all of my pumps have been scheduled out as well, together with peak and minimum load duties where appropriate. And finally, my buffer vessel has been sized and is sketched here as well. And there's an assumption that the buffer vessel will be used for sequencing of boilers on and off. So the control sequence for each of the boilers is shown in this schedule. So that concludes my demonstration of SystemGuru. Hope you found it useful, and please download a demonstration copy if you'd like to give it a try. Thank you.